Hello students, this lesson is about properties of exponents. First of all, an exponent. When I multiply things together that are the same, I get exponents. Like here I have a times a times a. A times a times a is a cubed. The 3 is the exponent and the a is the base. So I have 7 properties of exponents. The first property has to do with multiplying them together, taking the product. The product of like bases like this, a to the 5 times a to the 2. Well, what does a to the 5 mean? That means that you have 5 a's. And then you're multiplying those 5 a's by 2 more a's. Okay, so now how many a's do we have all together now? 6, 7. So really, a to the 5 times a to the 2 is equivalent to a to the 7. Instead of writing out the a's like this every time, there's a shortcut. The rule is that when you have the same base like this, you can just add the exponents, a to the 5 plus 2, a to the 7. So here's the rule. We add a to the m times a to the n is a to the m plus n. Alright. Quotient of like bases. When I have 2 like bases that are divided, what does this mean, a to the 5 divided by a to the 2? Well, that means we have 5 a's on top divided by 2 a's in the denominator. What happens here? Well, the 2 a's in the denominator cancel with some of the a's from the top. What's left? We have 3 a's left, so this is equivalent to a to the 3rd power. The shortcut is, instead of writing these out, I can just do a to the 5 minus 2. Our rule is a to the m divided by a to the n is a to the m minus n. Alright? Power to a power. So now we have a 5 on the inside of the parentheses, but the whole thing has been squared, raised to the power of 2. So that means that I have 2 groups of 5 a's. First I have 5 a's, and then I have a second group of 5 a's. Alright, so now how many a's do I have altogether? Counting them all up, I have 10. So the rule is when you have a power like this, you can just multiply 5 times 2. A to the m to the power n equals a to the m times n. We multiply. Alright, and now product, the power to a product. Now I have this group of AB, and I've raised the whole AB to the power of 5. Okay, that means I have 5 groups of AB here, if I were to write this out. Alright, 5 groups. Now, how many A's do I have here altogether? There are 5 A's. 5 B's as well. So what this means is that when I have a power on the outside like this, I just have to distribute. The 5 goes to the A and the 5 goes to the B. So, on this particular page, so far what we've said is that when you have the product, you add. When you have the quotient, you subtract. When you have a power to a power, you multiply. And when you have a power on the outside like this, you distribute. In this next one, we're trying to find a quotient. That's a division, 2 things that have been divided, and the whole thing is raised to a power. So, what this means is I'm going to have 3 groups of A over B. Alright, now when I multiply this out, how many A's do I have on top? There's 3 of them, and how many B's on bottom? 3. So this is equal to A to the 3 over B to the 3. When you have a quotient like this, again, you can just distribute the 3 to the A and the 3 to the B. A over B to the M is equal to A to the M over B to the M. Okay, 0 exponent. When you have a 0 exponent, that means that instead of having 3 groups or even 1 group, you have no groups. Anything to the 0 power equals 1. That's just a surprising fact that I am telling you and I want you to believe. Anything to the 0 power is 1. Any number to 0 exponent is 1. So my rule is 1. Alright, and then this next rule I can't really explain very well either. I'm just going to kind of tell you, when you have a negative exponent, you have to take the reciprocal. You have to flip it to make it positive. So, this a to the negative 5. Well, we can pretend like that's a to the negative 5 over 1. When I take the reciprocal of that, when I flip that fraction, reciprocal meaning flip that fraction, what I'm going to have is 1 over a to the 5. But now the 5 is positive. Now, you have to be careful because you don't want to take the reciprocal of the whole thing. You only want to move the part that's negative. Like, for example, look right here. We have x over y times a to the negative 3. The only part that needs to be flipped is the part that has the negative next to it, only the a. The x is going to stay in the numerator and the y is going to stay in the denominator. We're just going to move the a. So this equals x times a to the positive 3 over y. Alright, so those are all of our exponent rules. On this page, we can see that whenever we have a quotient to a power like this, again, we have to distribute. Whenever we have a 0 exponent, the answer is always 1. And when we have a negative exponent, you have to take the reciprocal. Okay, let's look at an example of using these properties. Okay, in this first example, the first thing you have to realize here is that those parentheses are not actually doing anything. Inside the parentheses, we only have multiplication. So we have this is multiplied to this is multiplied to this thing, and inside here we just have more multiplication. But multiplication is pretty cool because it's commutative. You can multiply in whatever order you want to. We can just get rid of these parentheses and write this as multiplication. Okay, it's the same as having all of those pieces, just multiplying them out. So now that I've written them all out, can you see that what we have to do is just take the ones that are like terms and kind of combine them? So, like the 3 and the negative 2. Well, 3 times negative 2 is negative 6. I'm going to put my x's together. Looks like I have 2x here and 3x here. Okay, well 2x and 3x, when I'm multiplying like that, what do I do with my exponents? I add. So 2 plus 3 is 5, so this is x to the 5. With the y's we have negative 2y and negative 4. Well, negative 2 plus negative 4 is negative 6. Alright, then we have z to the 0. Well, z to the 0, anything to the 0 power is just 1 times 1. Alright, and 1 times it, 1's not going to change anything. 1 times negative 6 is still negative 6. So next time I write this, I'll just forget all about that one. The only thing that we have left to do here, really, is to make this negative exponent right here, the negative 6, positive. So, to get that negative to be positive, I have to move the y part to the denominator. Right now, it's like the whole thing is in the numerator. And the answer is negative 6x to the 5 over 6y, and the y is now to the positive 6. Alright, so last example. I have parentheses here. Well, when I have this parentheses, I can just distribute to the inside of the parentheses. So I have a 2 here. I'm going to take this 2, I'm going to square each part inside the parentheses. Alright, now I have s. I take the 2 to the s. Well, I'm going to have to, what do I do with my exponents when I have a power like that? Well, with a power, I multiply. So this is 3 times 2, that's 6. This is s to the 6. T to the 2 times 2, that's 4. Okay, and then in the denominator, we're also going to multiply the negative 1 to each one of these things inside the parentheses. S to the 3 times negative 1 is negative 3. Negative 4 times negative 1 is positive 4. 2 squared is 4. Now I have s to the 6 divided by s to the 3. When we have a quotient like that, division, what do we do with our exponents? We subtract. 6 minus negative 3 gives me 9. And then I have t to the 4 on top and t to the 4 on bottom. Those two can just cancel. And then I still have a u squared in the denominator. So that is the answer.